Well, good afternoon, everyone. This is Kevin, also with MicroCAD Training and Consulting. I appreciate you all taking time out of your schedule to join us with our Leica Autodesk reality capture presentation this afternoon. And hopefully everybody's safe and warm and cozy and working from home and out on the roads with this crazy weather and storm Gale that's coming up the coast. So I appreciate your time. I'm going to get started here. Make some introductions on our side. Obviously, I'm your moderator, Kevin Austin, Vice President of MicroCAD Training and Consulting. With us today doing the presentation is Samir Rezik and Peter Bruckner, our applications engineers. They are our Leica scanner specialists, and we'll be doing the presentation in two segments. Samir will focus on the workflow from the Leica scanner to AutoCAD. And then part two, Peter will pick up and use that workflow process from the Leica scanner, the point cloud data set, and bringing it into Revit. Also, we have Wyatt Lee with us from Leica. He's here to answer any questions at the end of today's presentation on the hardware, software, and the solution that MicroCAD is presenting today. So now we've introduced our staff. We'd like to find out who out in the audience, what verticals that you guys are in: architecture, structural, civil, mechanical, engineering space, so we can kind of get a feel for who the audience is and where you guys are focused at. So we've just opened the polls. If you would just kind of select which industry that you're in, that would kind of give us a little better feel for who's in attendance. Okay. Look, it looks like we have an overwhelming majority of architectural and engineering from the AEC space, so that's great to see. We also have some civil engineering folks on there as well. So I think we've got something for everyone in today's presentation. The second question is really just to give us a feel and kind of gauge the level of interest and knowledge with regards to laser scanning. Sometimes I think you'll hear the term interchangeable between reality capture and 3D laser scanning. They're really kind of one and the same, but the industry really has migrated towards reality capture, but we'll be talking about that during our presentation. But it is 3D laser scanning using Leica software and hardware, and then transitioning it over to the Autodesk platform with AutoCAD and Revit. So thanks for answering those polls. A little bit about MicroCAD and who we are. Many of you attending this presentation are customers of ours, but there are some of you that are new to MicroCAD. We are an Autodesk Platinum partner. That's Autodesk's highest level awarded to Autodesk resellers for service, support, training with their platforms, the various AutoCAD software from AutoCAD, Civil 3D, AEC Collection, to Revit, and the BIM 360 platforms. We also sell output devices, specifically HP plotters and printers. We provide the maintenance and supplies as well. If you signed up on our website, you noticed that we also offer training online, custom and classroom based classes. Obviously, with the pandemic, 99.9% of our classes are online. We have found that the training actually has gone very well with the training application and software that we use to deliver the course content. Classes are kept smaller. The segments and the class durations are smaller chunks for our customers out there. So I invite you to take a look at some of the training classes that we offer. It's a wide variety, from updates to fundamentals to everything in between. We also offer consulting services that range from implementation to programming, support, customization, template development for the various platforms from Civil 3D to Revit. We have a support desk that's manned 8 to 5 with applications engineers with our level of expertise from architectural to engineering to manufacturing. And then lastly, what you're going to see today are our Leica laser scanner solutions. Specifically, the hardware platform we're going to focus on today will be the RTC 360. This is Leica's latest release in reality capture solution, and Samir will talk a little bit more about that. In the interest of time today, and obviously, giving the situation that we're all in with the pandemic, we're going to take you from the data collection that's captured with the RTC 360, which is a point cloud data collection set. We're going to take you from that aspect and bringing it into the Leica software, manipulating it, and then finally showing you how the process flows into an AutoCAD DWG format for part 1. And then, like I mentioned, for part 2, we'll take you from the point cloud into Revit on that side of things. So the data sets that we work with, the first one that Samir will be working with is more of a civil focus with an existing bridge structure that we went out and shot earlier prior to this presentation so that we had the data set ready for today's webinar. And then the second presentation that Peter will be doing that is Revit focused will show you I think it's a building, or I believe a residence space. So you'll get a good feel for capabilities of the scanner, what a point cloud is, and how to edit and manipulate that file and bring it into a CAD platform that you can use. As I mentioned, part 1 Samir will be doing, and part 2 Peter Bruckner will be doing. So with that said, I'm going to turn the presentation over to Samir Rezik. Samir, I will change presenters and make you presenter. Okay, Samir, it's all yours.
Thank you, Kevin. Welcome, everyone. I'm glad to have you all with us today. So let me start the presentation portion here. So today I'm going to walk you through the process a little bit. And the process really is comprised of capturing the data in the field, processing it, registering it together, all the setups, and then cleaning up the data. And then we'll manage it in various different ways. Today I'm going to manage it in AutoCAD, and Peter will manage it in Revit. And then finally we can also share the data with other people who don't necessarily need technical background, just need to review and see the point cloud. So the process is simple 4-step process here. So from the hardware perspective, we're going to capture the data using the RTC 360. It's the high-end laser scanner from Leica. That's also the one that we use for our services here at MicroCAD. The laser scanner is comprised of three main components. Of course, there is the scanning portion of it. It's very fast. It creates 2 million points per second. There is 3 resolution levels that you can choose from, and like a medium resolution, probably to finish a scan would be about a minute. So very, very quickly. It provides a scan at a dome, 360 degrees around the scanner, wherever that setup is, and a dome shape, so all around except below the scanner itself, where the tripod usually is. And also collects high definition images if you want it to collect images, and that will translate the colors of the pixels. The colors of the pixels will translate to the colors of the points in the point cloud. And that will almost take a minute to do. So again, in total, you're looking at a setup of 2 minutes. So very, very quickly. In addition to the 3 HDR cameras, it also includes 5 additional cameras that basically it's the eyes of the hardware. So unique to this particular scanner is the visual inertial system, which works with those 5 green cameras here, 2 on each side and 1 pointing straight up. And basically the cameras locate the setup, and using those cameras, it can understand the movement of the setups from one setup to the next as you're scanning in the field. So it reduces the amount of registering because the scanner itself is registering itself between a setup to the next setup. So I'd like to show you a quick video from the eyes of the actual scanner while moving from one setup to the other. So as you can see from this picture here, the HDR camera is right next to the scanner, but on the sides there is two other cameras here, and there's 2 others on the back side and 1 pointing straight up. And using those 5 cameras, in this video here we can see that the setup is located at the bottom right corner picture here, or video. That's where the person is looking at and holding the scanner and moving it to the next setup. The 5 other pictures that you see here is the actual scanner making the connections between the points. As the scanner being moved, it makes those connections between one location to the other. As long as it's being moved in a window of 2 minutes, it will register the next setup as it relates to the first setup. So very unique to this particular scanner here from Leica. So you can see the points getting connected, the green points with the red points. So it makes it very easy when it comes to back to the office to register this. Half the job is already done. So coming back to the office, would use one of the registering softwares that come with the Leica solution is Cyclone. Cyclone comes in many flavors, but Cyclone Register 360 is the latest, and makes it very easy to register the cloud. It is a multi-threaded application, so it's very fast performance-wise on the computer. And it has capabilities that's not available in other applications. So I'll take you through a quick step-by-step process. Once we collect the data in the field, we open up Register 360. We can import the files from the scanner. Usually the scanner has USB drives, saves the point cloud on there, and then you plug in the USB drive in the computer, import the point cloud. Files, various setups. Every setup is a file, and including the images as well. So you import the files. You can see on the left side here, I have imported 3 files. And then using Register 360, you can view the data, clean it up a little bit. There is 4 methods of viewing the True Slicer, the Setup Cloud, the Sitemap, and the Bundle Cloud. We're looking at the Bundle Cloud right now. As you can see, there is a cloud that was scanned, and there is the red bubbles here that resemble the setup locations for where I put the scanner. And using that, we can align the scans if for any reason we want to add additional setups and make the connections between one setup to the other. By default, the Viz technology is going to at least do 1, but we can add more. The more the better. And then this sitemap here, you can see there is 3 setups and they're connected. It also gives you the error value and the overlap between the clouds, the strength of the actual precision of the cloud, how it connects to other setups. So there is a very color coded. As long as you're in the green, you're good. But if not, you can then adjust the clouds a little bit. You can adjust it horizontally, but again, unique in Register 360 is the idea that you can also align the clouds vertically in elevation view, right inside the software here. So in this picture here, you can see one cloud is overlapping the other, but not quite right vertically. So we can really easy just to drag, move the cloud up and down to make it align. Sometimes there is a little rotation that we need to correct for. There is also correcting the tilt. Bottom left corner of the picture here, correct tilt button will let you rotate the cloud just slightly so that it's aligned. And then finally we export it. So there's a lot of ways to consume the point cloud after registering. We're going to talk about the LGS file export today. That's like a compressed file for the point cloud. That's also one of the ways that we can consume it and use it in other softwares using CloudWorx, another Leica software to actually model and use it. But there is also TrueView to be able to view the cloud in a web browser. You can export to a PTS or PDG, PTX. Those are common formats, as well as if at the end of the day, if we want to create an Autodesk recap file, again, that is also available to you right from Cyclone. So you don't need to take this data to recap or anything. You can export it right from Cyclone in a recap format. Today, the data set I have is going to be an export using the LGS file. And when you export it in an LGS file, you can then use CloudWorx to do things with it. CloudWorx is a plugin that can be installed in AutoCAD, Revit, and Navisworks. Helps you create the sections, slices, basically work with the point cloud in your authoring application. It also helps you create AutoCAD solids or Revit instances, family instances, right from the cloud. So trying to model it after that. And also helps you with clash detection between the cloud and the model elements. So I'll demo that portion in Civil 3D today, and Peter is going to walk you through the Revit portion of it. And finally, once we have it, maybe we want to share it with other people who don't necessarily need to use it in AutoCAD or Revit. We can use Jetstream as a centralized location on-premise or in the cloud to be able to house that point cloud and be able to see it. Comes with a viewer, so you can view it. We can work with it in CloudWorx. There is other flavors of Cyclone to model the objects versus using CloudWorx inside AutoCAD. We can just use Cyclone to model the elements there if we don't have access to AutoCAD. And then for people who don't have necessarily the Jetstream viewer, there is also TrueView, a way for us to share the data in a web browser. Anyone can see the point cloud through the web browser to be able to share it and review it and take measurements and things. So with that, I'm excited to show you what that looks like in Civil 3D. So from a civil perspective, I have the LGS file for a bridge dataset that Kevin mentioned. So once in Civil 3D here, once you install CloudWorx, it opens up a new ribbon for you. And all the tools that from Leica are right here. So I have an LGS file. I'll open an LGS file, select open LGS file. And then I'll browse to my dataset. And I'm going to bring it as a US survey feet unit because that's what my drawing is at. Hit OK. And that should show up. So right, just like that, it shows up for me. Very easy to navigate here. It doesn't regenerate every time you change your zoom level or navigation. It's just like very easy to work with. First thing I want to show you is using the tools to just maneuver. So if I flip here to the an isometric view, let's go to that corner. You can see that the vertical face of the building here is not really aligned with the view cube. So one of the orientation tools here that we can tell the software, we can align the view cube to the actual scan Z elevation. So floor and wall, basically select the road here I have and the wall of the building. And you'll see right off the bat that my view cube kind of updated to be aligned with the wall of the building here. That is my Z elevation. So now I'm aligned with the actual point cloud. I didn't need to do a lot of work to create my own UCS or anything. It just kind of does it for me. You can look at it in plan. You can take a look at the elevation view. So that's a lot of trees right now. So let's create some an area of interest. So I have the clipping tools, a lot of various different ways to clip the data. We'll clip it on the x-axis first. So maybe perhaps I'm looking at this bridge from here to there and not interested in a lot more data than that. I'll do another clip for the y-axis. And we'll go to the elevation view. And that is my bridge. Perhaps I don't want to see my steel members here, so I might want to take it a step down here. So just the road level. Clip it that way. So back again in plan view, I have a very nice clean look at my area of interest here without a lot of effort. This point cloud can be colorized differently. So right now is the true color, but I can also take a look at the intensity and see the intensity of the points. Makes it easy to trace along things. One of the items I want to show you here is maybe perhaps I want to trace the curb lines. From my perspective, that is probably the most important part for a civil engineer. So you can use the plain AutoCAD line command or polylines or anything like that, and you can, using plain AutoCAD, you can snap to points. The nice addition that CloudWorx provides is the Smart Pick viewport. So this guy is going to help you figure out what is it that you want to snap to here, the bottom of the points or the top of the points or the ground points. All of these points are classified. So with that, because they are classified, then we can let the software help us a little bit when tracing over. So if I have, like I'm interested in the top or highest points here to draw a line with the top of curved line. So I'll start the line command, all right, and let me change my line color here so that it looks a little better. All right, start the line command. And then you can see that my cross here is kind of towards the bottom of the curve, but my snap is appearing at the top of curve. And you can see in the little Smart Pick view window, my cross here is also pointing at the highest point right there, closest to my wherever my cross here is. So I can click and place again. And I forgot to change my visual style. So now we have the red line right at the top of curve. I'll do that one again for the bottom of curve. So lowest points in my smart view here, I start the line command again. And again, now my crosshair is about the middle of the curve, but then it's snapping to the lowest point of that curve. Makes it really easy to figure out where those lines are. There's a simple toggle to turn off the visibility of the point cloud. So if you want to review the line work that you created, I can turn off the point visibility. I don't need to unload it or anything. And then there we have the lines that I've just drawn. That was a pretty simple 2 lines there, but you would continue the tracing. I traced it pretty badly. Let's do that one more time. Yeah, I snapped wrong over there. I will do a high point. Zoom in a bit. And that would be my high point, and then we go to low point. And those lines are actually capturing the elevations, of course. And then, you know, obviously, you now continue on to trace along the road there and be able to see the lines now. Let me just double check that they are snapped correctly. So you can see that they're on top of each other. So very nice way of being kind of using the classification to determine where you snap, because you don't want to snap to every single point that we have in the cloud. There's a lot of points. Now to take this and create a surface out of it, usually we create a surface out of a recap file, and that would end up with a lot of jaggedy contours because there is a lot of points. In here we can place some points on a grid, and that way we're lessening the amount of points, only the points that we're interested in. We don't need every single point in the cloud for a surface. So I'll create some points, and that will create like almost like a DEM with a grid of points. So I'll put the grid here as maybe 5 feet. And then I'll say I want the classification of ground points. So I can have use the classification to my advantage here. I didn't create a fence. Maybe I'll do like a little box here. And let's preview the points. Now we have a couple of points, and I'm just gonna place them. Now I have a whole bunch of points. Let's take the visibility off. Now I can use these points to create a civil 3D surface. And let's take a look at the surface in the object viewer. So here is a really quick surface here. I didn't choose a big area just because of the performance right now with the GoToWebinar. But here is the surface, and you obviously add the break lines for the curved lines, but it looks a lot smoother than creating a surface of every single point that we have in the recap file or any other point cloud for that matter, because now we've just lessened the points a bit. And with that, I'm gonna turn it over to Peter, who's gonna walk you through the Revit component. So Peter, it's all yours.
Okay. Let me turn on my camera. Does that have me? Yep, here I am. And let me also share my screen with you. Just a minute. Show my screen. Absolutely. Come on. So are you seeing a point cloud?
We are, yeah.
Excellent. Now, this is one of the best things about the LGS file that is produced from the scan is that this is a scan that can be looked at by anyone. So it becomes an enterprise-wide scan. As a matter of fact, we took one picture just outside to give you an idea of what we're looking at. And this is basically a little shed that's been attached to a fairly large building where there are a lot of coal processes going on. So let's go back up to this view here and look at a particular view from within. So what you noticed, what this was looking at was all of the different setups. Each of those red dots is a location where the tripod was placed, where the scanner made its scan. And we can click at any one of them and look through the scan and see the objects. So this is one of those gnarly objects that you might need to measure and examine, but it's not an easy thing to capture. But with this scan, we've gotten it. But the other nice thing is we can take snapshots and we can also measure it. So for example, here's a snapshot we already took where we measured certain distances. Here's another snapshot with other distances measured. Now you can continue to measure additional points, like we needed to know what the radius is of this piece right here. So we'll just look at the radius right there. And that's 0.359 feet. And all I need to do is say, okay, add that to the file, and we've added that measurement. So consider that you can go to your site and measure anything, large distances, small distances, almost anything you wish to measure can be seen from your site. So that is a terrific advantage when you want to. So you scan it once, do a good job of scanning, and we're done. So I'm not going to, I'm going to save the changes. That's all good. I'm going to go to another scan now, which is for a house that we scanned recently. Again, many different scan sites, and you can go upstairs and scan at different levels. So we'll start off right here and just see how easily we can walk through the house and see what we're looking at. Well, so this is a scan. Measure anything we want to. Look around. You know, we needed to know what the height of that doorway is. All we need to do is grab the ruler, measure from there to there, and that tells us it's 6.668, which is a 6'8" door. So that's cool. But now, again, this is a particular view, or should I say a scan, the LGS file that can be used by anyone to look through the site. So you don't have to go back there. You're not quite sure what the width of the fireplace is, what those ceiling heights are, or anything else. It's all there. And we can look at it either as the points from the point cloud or the images. So right now I'm looking at images and point cloud superimposed over each other. Now, what's cool about that is we can also take that into a Revit file. So for example, right here, there's a Revit file of that very same house. So here we are going into Revit. As you can see, I've already begun to use the point file to locate some walls and windows. But again, what's really nice about that, and I'm going to turn around, for example, to show you how easy it is to create a wall. Now you can trace. It's very easy to trace walls. You can just simply look at a section and trace it. But there's much more you can do, because using the CloudWorx, we can actually say, well, I'd like to pick on a point and have you develop a wall for me. So I click on wall and pick a point. Okay. So I'm going to pick a point on that wall right there. And it looks around and says, gee, based on my records, it looks like you might want to use that wall. I said, actually, I'm going to use a generic 5-inch wall. It says, okay, fine with me. And as you can see, it sensed all the points on that wall and created a wall for us. Now you'll do that with walls, columns, and shortly we'll show you how you can identify structural elements. But then again, if we want to navigate this here, we open a thing called Open True Space. Now what True Space is that same view we had before of the file. I'll look at setup number 2 perhaps, right in the living room. And notice what it's doing. It's creating another view in Revit. And what you need to see is this is the view. It started on another screen. I just want to bring it into the screen. This is the view of the point cloud that we're looking at. You notice? But at the same time, it's creating that view within Revit as a view in Revit. As you can see, we've already found some walls to do things with, but I don't know any other way of navigating a point cloud that's as easy as this in Revit, because now we can measure anything, this height of a doorknob, any particular thing we wish to do, we can measure. In this case, I noticed that it overextended the wall, but I can always take that wall and edit in Revit back to where it belongs. So we always have the constant back and forth between the model and the Revit file. Now, I'm just going to go back into a structural model where we can, so I'm going to take Revit and thank you. I'm going to close this file. Just a minute. So I'm going to close this file. Do you want to close it? Yes. No, I don't want to save. Don't save the project. And I want to go into the bridge. So you saw the bridge before in AutoCAD. Now we're seeing it in Revit. Now, one of the neat things about the LGS file, as you can see, there's some real Revit elements, and very soon we will see the rest of the bridge. Again, a situation where using CloudWorx, we can open True Space, and so we're going to open True Space. Serious error has occurred. I hate that, but it happens. Just a moment. We're going to be back here. We're going to complete the external command. Close that. Open True Space. But I'm not going to save the recovery file right now because I have other things to show you. I can work for days and days without this situation, or I can be on a show and try to embarrass myself, and there we are. But let's just show you how this works to select members on the thing. So we're going to go to a 3D view. Now, the nice thing about this is we can identify any member. So for example, I'd like to identify this particular member here and build it in place. I will do that by telling it I want to build a steel beam. I can tell that it's a steel beam, and we can tell it that it's an I-beam. I can ask it to use a steel catalog, and I will choose this member from here to here. It's going to think about it. It's going to present me with a likely candidate, and I will click OK. And there it is. It's superimposed a real steel column right over the one in the image. You can see it's exactly in the right spot. So if you're trying to build a real world model from a scan, first of all, we've got amazingly high accuracy of the scan. And at the end of the day, we can build all of these elements right from Revit and create a proper model of these as-built conditions much quicker than anybody else could imagine. So that's my story, as I say, and I'm sticking to it. I'm going to bring you right back to Kevin.
Great, thank you, Peter. I appreciate that. Great presentation, Samir and Peter. And I will switch gears and talk about laser scanning options. I know it's a lot of information in a short amount of time, you know, with the workflow process from the Leica RTC 360 scanner all the way into the CAD application you saw today with AutoCAD / Civil 3D and Revit. So I want to talk a little bit about some of the scanning options that MicroCAD offers. The first option, obviously, and what we're seeing with a lot of our customers, just taking baby steps. You know, it's a big investment in the hardware and the software, and they're ramping up. Is the ability to outsource this service to us, where we'll come in, you know, with the personnel, with the hardware, software, or do the post-processing of the point cloud data to give it to you in something that you can use either in the AutoCAD format or Revit format. That's certainly option number one. Something else I want to make you aware of is we also do drone scanning, and Peter is one of our applications engineers, is also a licensed pilot. So we do a lot of drone scanning for a lot of our customers as well. So that's certainly an option, that a service that we provide should you want some additional information about that. Second option is customers like to rent the hardware and software from us to do their own scanning and post-processing of it with some services from us in terms of how to use the equipment, how to use the software. So that's certainly a second option. We see that a lot with customers that want to do kind of a proof of pilot or a concept before they make the investment. And then lastly is we're seeing this as really probably the most viable option for a lot of our clients, is making the investment in the scanner, in the Leica software, Leica scanner, and services, you know, to be able to provide that solution in-house. We've also seen it too, where a lot of our customers are now offering that service to their clients, believe it or not, especially in this time with COVID, for facilities management, all the social distancing, you know, the interior, exterior scans with regards to renovation projects. So it's really taken off for us. So like I say, we can do as little as you want or as much as you want with regards to laser scanning and a laser scanning solution. So I'm going to open this up right now to question and answer session. I know there are a lot of questions. I've had a couple of folks hit me up on the chat with a few questions. So I'm going to open that up. So please submit your questions. You'll see the little question drop down tag on there, and we'll try to address those as best we can, and keeping our presentation within the hour format. I do have a first question. And maybe this might be something for you, Wyatt. I had a customer is asking the question of what's a typical file size of the point cloud data that that you guys are using. You want to address that, Wyatt?
It's all going to depend on how much areas you're scanning, how many setups you do, how big the file was. I think in talking to Samir yesterday, he mentioned that that file that he used was about 4 gigs, if I'm correct. It's all going to depend on, you know, how many scans you're doing, how big of an area you're covering. The system itself is capturing millions and millions of points of data per second, so sometimes the files are going to be big. However, with the Jetstream engine and our compression engine, we're able to scale that down a little bit before it gets into AutoCAD or any of the other kind of CAD applications that are out there.
Good, good, thanks. Next question for the team. Customer has a Trimble scanner. Can they use the Leica software with the point cloud that's produced from their Trimble scanner? I guess that's another question for you, Wyatt.
Yeah, absolutely. Cyclone Register is basically a system agnostic kind of setup, so you can certainly bring in that type of data into Cyclone Register and be able to process it through to either an LGS file or industry standard format, E57 PTS, or even a recap file from there.
Next question, actually, you just talked about it with recap. We have recap in our AEC collection suite. What is the difference between what we have with Autodesk Recap and the Leica software? I guess another question for you, Wyatt.
I'll let Samir answer that one.
Or maybe Samir. Okay, Samir, Peter.
Yeah, they are both good. And we're not going to talk bad about Recap or anything, but Register 360 takes it's hand in hand. So if you're using the RTC 360 or the BLK, it's like the software that is intended for the hardware, kind of like iOS for the iPhone. They go hand in hand. It makes it easy that way. So it takes advantage of that Viz technology, for example, to register it for you easily, a little bit easier than Recap. But also, just like I mentioned with Cyclone 360, there is also the ability to align differently than Recap. So like, for example, Recap doesn't have a vertical alignment. So that makes it a little easier or more accurate, or gives us more control to do the processing. As well as another portion of Cyclone is the Cyclone Field app. So you can, as you are doing the field work and doing the scans on site, you can use the Field app on an iPad and be able to register and scan kind of both at the same time. So the Office component goes a lot down that way, because you're actually registering the cloud as you are sitting and waiting for the scan to finish from one setup to the other. So it's just a different software, and it's more tailored for the hardware that we're using. Whereas Recap is more of a generic registering software that works with any kind of data sets.
Great, great. Thanks, Samir. Another question, does Leica have an option to share point cloud data in a web-based format, i.e. for consumption by an outside client or layperson?
Well, I think this is Peter. And by the way, the little glitch we had, I clicked it again and it went back, but that's another matter. Yes, you can create an RCP. There are a number of different, your PTS files. So all of the standard point cloud files are there. And as you know, with Autodesk products, you can always bring in a point cloud very, very easily. The big difference is the LGS file, which has many more dimensions in it and ways of moving around it. But you can definitely use the Register 360 to output different point cloud types.
Okay. Yeah, you can also, let me just jump in real quick, Kevin. You can also view that data in a web browser with the Jetstream. You're able to view that, no problem. There's also another application that we have called TrueView that gives you the ability to share that data in a web format, and allows you to do markups and annotations and things of that and share data back and forth. So we do definitely have a couple of options for those capabilities.
Okay, great. Another question for the team. Is CloudWorx part of the cost of the RTC 360, or is this another software that is priced separately? I guess more for you, Wyatt.
Yeah, that's a separate software application. There's no software that's really built into the systems themselves. There are additional software components that you need to purchase to make it work optimally.
And there are different bundles out there I can maybe add to that as well, that depending on the specific solution that the customer is looking for, we'll make sure that we bundle the right software application with the RTC 360 scanner device. So certainly reach out to us, and we can talk to you a little bit more about some of those needs. Let's see here. I'll take another question. What type of volume do you need to get an ROI on investing in an RTC 360? Good question. Wyatt, I guess this is another one for you.
Well, it depends on, how much time you're spending doing the processes that you're doing, that you're looking to replace with a scanning solution today. So if you were either outsourcing that to a third party, or if you're going out and measuring an area by hand, how many people are you bringing to that job site? 2, 3, how much time is spent there? Are you having to go back out to that site to revisit it because you missed something, or the calculations were just off, what have you? So those are all the things that you need to work into it and kind of build that ROI from there. Any of us, Kevin or I or myself, can help you with some ROI information if need be, and definitely something we can talk about it, but it's going to be specific to your particular situation. And we try to work with you to kind of customize things that are going to work best for you.
Thank you, Wyatt. Next question is from, let's see, I would assume the longest time will be that of producing the Revit BIM file rather than being on site, collecting the data from the RTC 360. That depends. Yeah, go ahead, Peter.
Actually, the amazing thing is, for a couple of hours on site, and I like to scan the heck out of it, make sure there's every viewpoint. Remember, anything you want to see needs to be seen from at least 2 different points, at least 3 points. But if you do a good job on site, you basically brought the entire site back to your computer. You don't have to go there again. So if you're dealing with sites that are hard to get to, or you need to know anything, all of a sudden, if you've done a great scan, you've got all the information you're ever going to need, and you can tap it at any point. You can measure it. So I think that's the advantage. Yes, obviously it's going to take more time to do the BIM model, but again, an advantage of using something like CloudWorx rather than, and I've done it both ways. I've taken a regular point cloud into Revit, and yes, you can trace it and figure it out. But when you have CloudWorx that you can actually capture, and it'll detect planes and put walls in the right spot, you're going to get there a lot faster and a lot more accurately. So that's basically it. I just do a great scan, spend half a day maybe on site, and you've got something that you won't have to go back to the site for.
Thanks, Peter. Last question, and I know this is kind of an open-ended question for the team, but how long does it take to scan a single scan on the highest point cloud setting? You guys want to address that?
2 minutes.
And
241 actually.
Okay.
241. Okay. Let's see. Maybe we got time for one more question here.
And let me just break that other one down a little bit further. So it's a minute 41 to capture the point cloud data, and then you add a minute to capture the high dynamic range imagery. At any of the setting level, it adds a minute to capture the photos.
Yeah. Last question, and this is a good one because we didn't cover all the Leica scanners. We focused on kind of the workhorse, the RTC 360. But a question from the audience: are these captured with the Leica 360 BLK, and can the same files be acquired from the RTC 360? Wyatt?
Yes, you can capture similar types of data with the BLK 360. You're going to capture more data with the RTC, and it's faster because it's got it captures 2 million points per second as opposed to the BLK 360 that's 460,000 points per second. But you're going to still be able to capture a lot of data. You're able to get into some areas with the BLK 360 because it's a smaller footprint, kind of the size of a Coke can, if you will. And you might be able to get into some tighter areas to be able to get good scans from that. You do have to do more scans because the range isn't as good as it is on the RTC. But you're still able to capture high quality point cloud data that will be beneficial in either case by capturing that data.
Good. And just for the audience's edification, the data sets that you saw today, the bridge, the house, and the coal site, were all done with the RTC 360 scanner. So good. Keeping it to a 60-minute time limit, I appreciate your time and attention. Thank you, Samir. Thank you, Peter. Thank you, Wyatt. I left my contact information on the screen. We'll also be sending each of you, the attendees, another link. We are doing some promos for year-end purchasing for IT expenditures and so forth. I do want to call to your attention, there are 2 handouts that are attached to this webinar that are Leica spec sheets, and also talking about the Viz technology or the RTC 360. I certainly invite you to download those. You can also visit our website. There are links to a variety of Leica scanning videos that are up on YouTube. And so thank you for your time, and stay safe out there. Bye, guys.
Thank you, everyone.
So long.
Nice job, everybody.